Welcome to our today's Ravenna webinar, OEM Solutions for Ravenna AES67 and 2110. This is the fourth seminar in our series of summer webinars. We'll start right away. Today, I will have several co-presenters joining me on this call. And a quick look at the agenda. We will have about 15 minutes introducing the panel and an overview on the current status of the two most relevant standards here, AES67 and SMPTE ST 2110. The 60 minutes is being reserved for the individual solutions my co-presenters have on offer. And then we will have about 50 minutes at the end for panel discussion, question, answer, anything which may come up or might have come up during the presentation. So this is a 90-minute session today. So let me introduce the panelists quickly. We have Claudio Becker-Voss from DirectOut, Germany. We have Claude Cellier from Emerging Technologies based in Switzerland. We have Bill Renopoulos from Ross Video based out of Canada. Good morning, Bill. And we have Ari van den Broek from Archwave Technologies based in Switzerland. And of course, myself, I'm Andreas Hildebrand, working for ALC Networks as a Ravenna evangelist. So before we start into the building blocks the various partners have on offer, we have a quick look into the current status of AES67 and SMPTE 2110. So as everybody knows, AES67 had been actually published in 2013 and received a second revision in 2018. So the question is, what has changed since the initial publishing and the first revision? So what is the particular reason for the AES67 2018 revision? Well, as in the previous revision, we had adjusted some minor, ambiguities. We had added clarifications and done some correction to the standard. Particularly, we have added a sender keep alive recommendation for the unicast transfer mode. We have adjusted wording on the MTU requirements in the presence of optional RTP headers. SDP examples were corrected, or in other words, aligned with the then changed RFC 7273. For those of you who don't know what that is, that's the clock synchronization, clock reference and synchronization standard issued by the IETF, which is very, very important for AES67 and SMPTE 2110. And we had a correction in the PTP domain number range. Then a very important thing is the Pix, which has been added. Well, we are not talking about this little animal here, but Pix is the abbreviation for Protocol Implementation Conformance Statement. So what is a Pix basically? A Pix is can be used to self-test proper compliance with the AES67 standard. So the manufacturers basically have a tool to test all the mandatory and optional requirements which are written into the standard against their particular implementations. And also a published Pix document would be a very useful document for implementers and system planners to see if the particular optional features of those implementations are matching their requirements. So the Pix basically is every individual requirement, which is in this sometimes weird standard language, has been extracted from that and put into an Excel sheet. You can see we have the statement number, the feature which is described, some explanatory notes which were probably missing from the standard to give a bit more in-depth explanation what is in the standard, what is meant by this particular features. And then very important, the requirement level. So we have a requirement level in the standard. A mandatory requirement numbered by 1 is always a shall requirement, so that has to be implemented or fulfilled by the particular implementation. as required by the standard. Then we have should, which is a strong suggestion there, and we have may features, so implementations may support something. And then we also have some just informative lines in the standard. So this is the color coding, which is important for the compliance specifications. And finally, the implementers can check yes, no, or doesn't apply in particular cases. Now this Pix document is an normative addendum to the AES67 2018 standard, and it covers 28 pages of Excel lines. Since this is quite a lot of work, and also even more work to read and understand what is written in there, or how the compliance of a particular implementation actually is against AES67, we and that's the standardization group, came up with a so-called Pix Summary Document. This is just a one-page sheet where the implementers, the manufacturers, can mark the most important features and those which have a variability, so that anyone interested in that particular implementation or product can immediately see what requirements are fulfilled by this particular implementation. So it can, for example, look at the sample rates, if multicast and unicast is supported, the QoS markings are marked there, the supported packet times, and many more important features which can be judged just by with one view, with one click on the document. So that is basically what has been added to the 2018 standard. The development on AES67 hasn't stopped, so we are continuing improving the standard wherever necessary. For example, we have work underway where we are looking at the requirements which are set forth in SMPTE 2110-30 and the ST 2059 Ptp profile, so that we harmonize the requirements between those two standards. Multicast addressing is something we are discussing at the moment. For those of you who are very deeply inside the standard, AES67 calls for using the 239 range of multicast addresses according to some IETF or RFC guidelines. SMPTE 2110 would allow other numbers for the leading octet. So this is currently under discussion. Some SDP SIP improvements are currently discussed, and recommendations for wide area network usage and redundancy recommendations. So just a few points which are currently under discussions. I can't exactly tell which of those would make it into the next revision of the standard. Then the group is also in coordination with SMPTE and VSF, planning and organizing Plugfest. Basically, we are inviting everyone to join the AES67 task group. Basically, everyone who has a strong interest in AES67 can join, and it's not limited to manufacturers, but also broadcasters or interested individuals can join and contribute to the ongoing standards maintenance and evolution. All right, that's AES67, a quick look into the SMPTE ST 2110 suite of standards. The professional media over managed IP network standards is a suite of standards which specifies the transport and synchronization of separate elementary essence streams, so audio, video, and ancillary data being transported as individual separate essences on the network over managed IP networks, and the main application area is real-time production playout and other professional media applications. So there's nothing for over-the-top or internet-based transport of media essence. So just in order to illustrate the difference between the already existing bundled approach, where we have an SDI signal in one stream, audio, video, and metadata, traveling in one IP stream, versus SMPTE 2110, which is the essence-based approach, where all the individual essences, audio and video and metadata, travel as independent, separate essence streams on the network. So the bundled approach, again, we have all the ingredients of an SDI signal, the active image area, the audio, which is contained in the horizontal ancillary data space and some additional metadata like timing, subtitles, etc. They are all encapsulated in an individual or in one multiplexed IP stream. The standard is the 2022-6, which is very useful for distributing already produced signals across facilities. Now, 2110, the essence-based approach basically is extracting the active video portion of an SDI image and is forwarding that into an individual stream. The audio is being extracted and is being transported as an individual stream. And the additional metadata is also an individual stream on the network. All these streams can be fully synchronized, sampled accurately with the very same means as AES67 uses with a precision time protocol. So that's basically the difference between the two approaches. Final look at the document structure of 2110, because it's not just in one document, it's a number of documents. The -10 document describes everything related to system timing and required definitions like the transport layer, synchronization, etc. -20 defines how uncompressed active video is packetized into the RTP payload. So we're not talking about compressed video, it's uncompressed raw video without any additional data. We have the -21 document, which describes traffic shaping and delivery timing for these massive amount or huge bandwidth video data streams. -22 has just recently been published. It talks about how to load compressed active video at constant bitrate encoding into an RTP payload according to 2110 requirements. Note that there is no particular codec being defined. So any constant bitrate codec could be used to transport video in a -22 stream. Of course, the receiver would have to know what particular codec is being used, but this is out-of-band communication and not part of the -22 definition. You might have heard recently about JPEG XS, but also J2K or VC2 or others might be used for -22 transport. Then we have the -30 document, which basically is an equivalent to AES67. It defines the PCM digital audio transport, so linear 16 or 24 bits of audio. How is that being transported across the network? Then we have the -31 document, which covers the AES3 bit transparent transport. So it's not just the L24, the 24 bits of audio data, but also the additional 4 metadata bits, which are defined by AES3. So that basically any payload, not just audio, but any payload which is being defined for AES3 can be transported bit transparently across a network with an IP stream. And basically the whole -31 standard refers back to a payload format which Ravenna had already in place from the very beginning, the AM824 payload standard. And then -40 covers the SDI ancillary data transport. Under development in the 2110 standardization group is the 23 document, which covers high bandwidth signal transport, so that let's say high frame rate camera, motion capturing cameras can transport their essence in individual valid -20 streams. So the system defines how to separate or distribute the data into several individual streams and how to realign them. And then we have the -24 document, which covers the transport of single SD or single definition video signals. And a very important standard is the -41 standard, which is currently in the works, which covers extensible fast metadata transport. So anything which goes beyond the SDI ancillary data is what we are looking at here. For example, audio object metadata or any other data which is of importance to a particular production, which typically is not defined by the SDI ancillary data. That is something we look here. And just for those of you who are into standardization, the AES has another work group who's working exactly on the same topic, and there's alignment between these two groups in order to not have two different standards at the moment. So for those who are interested, the X242 working group in the AES standard. So that concludes the overview on the current SMPTE 2110 and AES67. I've listed further work which is currently going on. I'll just click over it because that's not very important for our today's presentation. So that's for the quick introduction. And now we continue with the different building blocks and approaches our various Ravenna partner companies have on offer for implementing AES67 and 2110, mostly audio, but some of them also offer some video solutions. So it's up to Claudio Beckerfoss from Direct Out to take over.
Thank you, and yeah, thank you all for joining the webinar today. And yeah, I'm Claudio Beckerfoss, the CEO, CTO of Direct Out. And yeah, Direct Out has been a Ravenna partner since the beginning. We joined very early, as soon as Ravenna was revealed to the industry. And one of our first implementations, our first product with Ravenna implementation was the Montone 42, Ravenna MADI converter with 256 channels in and out as a bridge between audio over IP and standard MADI. So this was our first take on implementing audio over IP and implementing Ravenna. And since then, our implementation has well changed and improved a lot. Many feedbacks from our customers and from projects, experiences from projects, made it into our implementation and improved it a lot. Direct Out joined the standards committee for AES67. So as soon as that was defined, of course, we made sure that all things that come with AES67 are also supported and implemented in our implementation, and made that available, like Unicast, for instance, which was not in Ravenna from the beginning. And yeah, we just published also the Pix Summary, so you can look that up for our products as well, as Andreas just mentioned. And after a while, when 2110 came up, we again implemented the few little things that need to be added to be compliant with that. And in the end, actually, the Montone 42 was even the reference device for the JTNM tested program that happened last year and this year as well. This year, a bit compromised due to the situation all over the place and the world, but still, it's a program that looks at the ST2110 implementations on the market, and any manufacturer can take part and check how the devices work together, how the implementations interoperate, and it's a helpful list of results for implementers, for system integrators, system planners to check out which devices support which parts of the standards and what you can achieve with that. Then last year also we published our new converter series, the Prodigy MC and Prodigy MP. Prodigy MC is a converter with up to 64 analog mic line or AES IOs plus 2 times MADI, and of course a network module. And the Prodigy MP has 2 slots for network modules and also DSP capabilities for EQs, dynamics, SRCs inside. And for those boxes, we needed a Ravenna module, which looks like this. We have 2 types now, just a standard Ravenna IO, and we will soon publish the Ravenna SRC IO, which will then have SRCs for all the Ravenna channels in and out. And as you can already see on this module, there's a little mini PCI module, which we now also offer as an OEM solution for those who are interested to implement Ravenna as well in their devices. The features, well, contain, of course, the complete Ravenna implementation, as we have it available for Montone or for our devices as well, including AES67, including 2110-30-31. And audio-wise, it provides 128 IO channels that can be put together in up to 32 multicast or unicast streams with sample rates up to 192 kilohertz. Network performance has a big variety there. We can go down to 1 sample per packet. So for very low latency streams, this is supported on a per stream basis by the module. But also for instance, for WAN applications where a huge buffer is required to accommodate the packet jitter, the device provides up to 500 milliseconds or even more to accommodate those packet jitters and make sure the stream can still be received properly. We offer ST2022-7 for multicast redundancy, and our implementation even works for unicast as well, which is not defined in ST2022, but still it's possible to use it. So for the reliability of providing streams and exchanging streams between the Ravenna devices, it's taken into account and taken care of. On the Ptp side, there's a built-in Grandmaster, so the module can run on its own behalf. It can be synchronized to an external source like word clock or video sync. But of course, it can also synchronize to Ptp in the network. We support multicast, hybrid, and unicast mode for Ptp, which is quite helpful, especially in bigger systems. And we implemented some adaptive filters that again are very helpful in case the Ptp transmission is not ideal, for instance, in a network where no Ptp-aware switches are available, or even if you have to transmit Ptp over WAN because there are no GPS links available for some reason. This can help to still be able to synchronize even if the Ptp jitter is very high. Of course, this jitter can be measured and displayed. I will show you in a minute how this looks like. And for the remote control, we have a configurable, we have a web interface that can be used to configure the streams and the whole module, and also a backend towards the host device where the configuration can be done. There will be NMOS available, ISO 4, ISO 5, to control the streams from the network, from an NMOS controller or a central stage. And yeah, the configuration protocol has also been made available to a couple of network orchestration companies that provided a driver to control our module. So this is also an option that can still be used. The management and streaming ports can be independently assigned. So if for each stream you can decide which network port you want to use to stream out, or maybe you just want to keep it for control purposes. So now I will switch over to the actual surface. I show you here my screen, better like this. So this is the web surface actually of the module. You can see here are some streams already active, input streams on the left, output streams on the right. And there's a logo on the top. So here's another one with Stage Tech branding, who is one of our OEM customers. So this is what you can get in any case. If you're an OEM partner, you can get a branding for this interface to make your customers feel comfortable. And yeah, just a quick look at the stream configuration. Of course, we offer all the Ravenna session protocol via RTSP. So all streams show up here that are available on the network. But we also implemented the sub protocol, which is required if you want to work with Dante devices. So by that, we can see, you see here the list is quite similar. So the Ravenna streams show up as well, but also the two streams coming from Dante devices in my network here, the Xbox MD, which is a Dante MADI interface, and a Prodigy device with Dante interface. And the other way around, if I set up a stream, it's also announced as a sub announcement. So if we look at the Dante controller here, you can see that all my streams show up here. And if they are AES67 compatible and compatible with the implementation of Ordinate, then you can just set the patch here between a Dante device in AES67 mode and our module. So this is a very convenient thing to exchange the SDP and the stream configuration. We also have, of course, a manual way to configure the stream data in case you only get SDP as a text file or as information, written information somewhere. So you can really manually edit all parameters of the stream, anything that might be required to configure the connection and then connect to the stream, even if a device does not support any discovery protocol. As you know, probably AES67 does not describe a certain way how to configure a stream or how to share the SDP, so to say. So there's no discovery described in AES67, and that in some cases you might need to do that manually. So this is of course possible here. And just a quick look at the Ptp configuration. You see here on the left, we implemented some profiles that can be used out of the box, but of course you have also a manual way to configure all the Ptp settings that might be required in your particular setup. So this fits in nicely into any system, and you can really adjust this according to your particular application. Here in the middle, you see info part where you can, for instance, see the Grandmaster ID, where this device is currently synchronized to, and also the IP address of that Grandmaster. So this is currently 210, which is my device here, which is currently Grandmaster. You can see this here as well. So this is currently synchronized. And if we look down here, we see the Ptp jitter statistics, which look not so good right now. And if you look at the jitter graph here, it's quite jumpy. The reason is that I switched off any Ptp capabilities of the switch I have here in my network, which is a Cora 1G, which of course supports Ptp. But just to show you the jitter situation, I switched it off. Now I will quickly load a configuration with boundary clock, and you will now see that the jitter is reset. The device resynchronizes, and once the boundary clock has been settled, you will see that the jitter results are much better now. And you can also see here the IP address has changed of the Grandmaster. So you see now that the module is now synchronized to the Cora switch, which is a boundary clock. So these informations here are quite helpful to troubleshoot also, and yeah, to see what's going on, to monitor what's happening. As a last thing, we have also this page where you see the bandwidth which is currently used in the device, and yeah, some other information. So this is quite helpful and is available on any module, of course. So let me switch back quickly here. For more information, yeah, just send an email to oem@directout.eu or visit our website. And yeah, also I'm here, of course, towards the end of the presentation for the Q&A. So thank you for now. Andreas, do you want to take back control?
So that was Claudio Beckerfoss from DirectOut. Next up is Claude Cellier from Urging Technologies. Claude, are you still with us?
I'll check. Maybe you can see me even if you don't hear me.
Yes, there you are. And you have control on my screen now.
Excellent. Welcome, everyone. Thank you very much, Andreas. I want to even thank you more so as my presentation all starts with a little bit of history, and I would like to testimony here how much we enjoyed you being the top chef introducing us to Ravenna and to the recipes of Ravenna some 10 years ago now.
Yeah. Thank you, Claude. Very welcome.
So I'm going to stay a little bit in culinary principles because, as you can certainly guess, we're here not to talk only about the dessert, which would be the end of my presentation with the OEM module that we do also propose to OEM interested parties. But for a real banquet, you need also hors d'oeuvres, you need pasta, you need glue, in salsa, in main course, and of course some good drinks to go along. And my presentation here is initially starting with some other core components that merging did develop to entertain the entire Ravenna AES67 ecosystem. And some of these pieces are, of course, useful in the overall industrial acceptance of that protocol, since you want to be able to not only talk Ravenna and AES67 between different hardware equipment, but you also want to do that between computers. And we have even three major tastes of computers and OS systems, the first being Windows, then Mac, OS 10, and then Linux. And we've been working for all of them. And if I had to review it these days, if I had known how much of maintenance those silly pieces of technology take, I may have not started in the first place with my team. Let's go forward and see a little bit what these systems and virtual audio device drivers do. The first one I'll talk about is the Mac version, which is the one we designed already probably some 4 or 5 years ago. And that alone is a huge pain to maintain. To develop, it wasn't easy, but then to maintain, as Apple went from Sierra to High Sierra to Mojave, and then more recently to Catalina, I can guarantee you that at each version, at each revision, we have to invest between 1 and 2 months of engineering to make it work again, because for some unknown reason, they are even better than Windows or Microsoft at making sure none of your previous assumptions still work. Nevertheless, here we are. We offer to the entire community and free of charge a Ravenna and AES67 virtual audio device, which works under Core Audio, which is the aggregation of audio system in Mac system, which is very well designed, by the way. And we also have a premium version, which is available to our OEM customers, of course. The support for NMOS is being integrated as we talk and will be released this summer as an additional option. Let's take a look at the main difference between the free of charge standard edition to your left and the premium edition to your right. For all basic work, the free of charge version is entirely sufficient. It supports, as you can see, for both have in the past supported all since Yosemite, El Capitan, Sierra, High Sierra, Mojave, and now more recently Catalina of OS versions. The latest Catalina is 10.15.2, and I think we are about to announce 10.15.3 support. Both versions, of course, support 44.1 and 48 kilohertz sampling rate, whereas the premium edition goes higher, supporting 96 kilohertz up to 384 kilohertz DXD and DSD as well. In terms of supported channels, the standard edition supports 64 ins and outs, which is, I'm sure you'll agree, more than sufficient for most jobs. The premium has an extended channel count up to 128 inputs, including at all the higher sampling rates up to DXD and DSD. Of course, this is going to be potentially limited by your hardware, by the performance of your Mac computer, but it should be the system's limitation rather than our own limitation. All these functionality is, of course, also enhanced by additional MIDI control in the premium edition, where you additionally are able to control your endpoint, preamp, or other MIDI functionality in your devices. Both systems are seen by what we call MT discovery, and this is also quite elegant. I'm not going to go into too much details. I think that's enough for that presentation of the Mac support. On the user interface side, you have a very simple settings page where you can decide about your latency. Here you see the typical mandatory AES67 48 samples block size selected. You can, however, also select higher and lower block sizes. The sampling frequency, there is no SRC at this moment here, of course, in the system, so you have to select your sampling rate frequency. And below you have a simple place to decide how many input channels and output channels maximum your driver should support. This is, of course, to avoid maxing out your Mac system's performance if you do many other tasks in parallel. If we look now at the Windows side, we have, of course, not Core Audio. Core Audio is a typical Mac audio support, but we do have what is called ASIO on the Windows side. And we started, of course, with Windows 7, then Windows 8, and now we, of course, recommend Windows 10. The situation here is a bit different than to the Mac environment, because here we have no totally free of charge version. We have a free of charge version, but it requires the presence on the network of at least one of merging network interface devices, which can be Horace, a Happy, or Anibis. Or it can be one of your own products if you use our OEM card, which I will mention as a dessert in a moment. If we look at the history of our Windows support, it was quite limited compared to the comfort of what you get in the Mac environment. So we decided to invest a big additional chunk of energy, and we have now expanded our ASIO driver into becoming multi-ASIO, plus including WDM support. So you essentially are now in a position to send or receive audio channels from your Windows environment via several similar simultaneous devices or audio sources, one being the streaming of audio on Qobuz or Spotify, while you have other audio channels like we have right now via GoToWebinar or via Skype, plus additional sound sourced by your digital audio workstation. So this is currently the latest additions to the Windows ASIO support, with coming also this very summer an optional ST 2022-7 support, which we also are currently validating with a major broadcaster who actually not only wants to test that in a standard Windows environment, but in a virtual machine deployment, which is, of course, adding thrills to the experience. Finally, and that's, of course, important for some of you listening this afternoon, is we have also support for NMOS that is in final beta testing right now on Windows, and that's also planned as an additional option. So these are the main elements of our ASIO support. Here again, you see a sheet with the main elements of the Windows virtual audio device. As you can see, we support different latency frames like 6, 12, 16, 32, 48, 64 samples. This is allowing different types of latencies. Here also a number of input and output channels are supported, up to 128 at 1FS, 44.1 and 48 kilohertz. And we, of course, divide by 2 on the Windows side. Each time we double sampling rate, ending up at 16 inputs and output, still at 384 or DXT sampling rate and DSC. Windows 10 is, of course, recommended, but Windows 7 is still supported, and we'll keep that going until it's humanly possible, but on 64-bit versions, of course. Let's move on to the Penguin operating system. here we have, since now 3 or 4 years, put a considerable energy in creating ALSA Linux driver as well for Ravenna and AES67. It comes in 2 flavors. One is a public build for non-commercial applications, basically available to anybody interested. And we have regular interest of people who want to do it yourself approaches, etc. Plus, we have an OEM build for commercial products integration. So don't be afraid to contact me or our contact at the end of my presentation if that's of interest to you. We support up to 64 I/O channels on the OEM build, and of course the non-commercial application is limited to 8 channels. This is a rapid overview of this Linux virtual audio device, which offers a simple butler, which is requiring a proprietary license. You have your own user application talking to the ALSA driver, which is in public library form, and you under the ALSA driver control the Linux kernel. It's pretty a classic way of working in Linux. After these appetizers and hors d'oeuvres, let's come to the what I call the pasta dish, which we decided to contribute also to the entire AES67 ecosystem. Animan is the audio network manager, which is a top level. It's not really an orchestrator, it's rather a controller of all the things that need to be seen, reviewed, connected to in a network. It allows you to discover equipment, to save and load connections, and it is already supported by a number of third-party companies, including Lavo, Archwave, Direct Out, Ross Video, and many of those you will hear from them as well today about their own products. There is an enterprise-grade version of Animan, which is also available for larger scale projects. Essentially, to see how it is giving you control, this is how it looks like. You have an overview of your network with your devices, your various devices, and immediately see which number of channels are being shared between devices. You can even see different networks which are separate in functionality since they don't talk to each other. This is the world view. Here underneath, you have a devices description where you can quickly home on every equipment in your network and see if there is any fault, any difficulty, or error message. While on the right side, you get access to the routing page, which is, of course, quite fundamental part of Animan. So that's the way we offer the interoperability between all these devices so that each manufacturer in AES67 can see other devices working together. If you want to have more information on Animan, we had recently, Andreas organized that just last week, if I remember well, a full presentation on Animan hosted by Nicolas Sturmel from Merging, and the recording is available there. Roland may give you the details of it in the chat as well. I'm now off to conclude my presentation with our own little compact system on a module solution for Ravenna and AES67, which is based on system on a chip Xilinx Zinc part. You have here essentially audio specifications with sampling rate from 44.1 to 192 kilohertz. You have an optional high resolution support for DXD and all these fancy ultra high resolution sampling rate. So that works in these modules as by standard default. We offer word length of 16, 24, and 32 bits with access to audio ins and out over I2S or TP. A large audio buffer, as Claudio said before, representing a good third of a second, if not more, per channel. We support up to 32 Ravenna I/O streams on up to 256 network audio channels. And when I say 256 network audio channel, it's actually 256 ins and 256 outs on the higher grade module that we offer. I move rapidly over the hardware specification. One important thing is the last bit of information here. It can be useful for some of our OEM that has been highly appreciated, that is pin compatible to Dante Brooklyn 2 with a mini PCI form factor. So users who have already integrators who have worked with Dante can almost plug and play with our module on replacing those modules. There's an additional software support in those modules, which gives you access to a routing matrix of over 500 channels. So you can route in and out over 500 channels. You also have a real-time mix engine of 128 by 32, and additionally 28 bands of EQ. So that comes also with our design. You may not need all of that, but it can come handy because compared to a simple I/O module, our module has extensive processing capability that comes along. Let's get to the final bit of my presentation. Here you see the, sorry, I went a bit too fast. Here you have the entire block diagram of a typical OEM implementation with ADC, DAC, AES, I/O, MADI that can be connected to that module. The gigabit Ethernet switch here, pretty simple to deploy. There's two versions of it, what we call Z-Man 010, offering up to 64 by 64 channels at 1FS, and the Z-Man 020 offering 4 times larger channel counts at 256 by 256. And last but not least, we just went on making sure NMOS was also supported in our design. So it's available to our OEM broadcast customers, and we have different companies right now selling already NMOS to their customers. ST 2022-7 is also under validation by a major broadcaster, but up to what we managed to test here, everything was properly working 2 months ago in March when we participated virtually in the self-test of joint GT and EMA. Okay. Sorry for taking a little bit longer than I was planning to do. Here you see a final view of that board, that OEM board with OEM simple kit, a development kit with already 2 gigabit Ethernet connectors here, SFP gigabit additional connector, AES-IO, etc. So you can also quickly start having a running functionality out of the box. I thank you very much, and I hand over back to you, Andreas.
All right, thank you, Claude. That really was very interesting, but however, it used much more of the time we originally scheduled. Anyway, okay, it's fine. Without further ado, I hand over to Bill Ronopoulos, who is sitting in Canada. So good morning, Bill, and I should make you now capable of controlling the screen. So Bill, it's up to you.
Hello, I'm Bill Ronopoulos, Business Development Manager for OEM and Partnerships at Ross Video. This year is the 10th anniversary of Ravenna, and we are hoping to celebrate it at some point. But what I'd really like to thank is, I'd like to echo Claudio's sentiment and really thank Andreas for organizing this and tirelessly giving to the Ravenna community for 10 years now. So thank you, Andreas.
Thank you, Bill. Thank you.
So today, I'd like to tell you more about our very popular Bach audio over IP portfolio. The Bach family gives your products the freedom and power to perform across markets with our embedded live audio 2110 and AES67 modules, chips, and software. Bach offers a comprehensive set of embedded audio and networking solutions, enabling your products to play in multiple networked environments, complete with control and protocol support for Ravenna, SAP for Dante, QLAN, and Dolby interoperability, NMOS, Livewire Plus on certain products, Animan is being introduced, and Ross Dashboard. On the next slide, from the highest capacity 10 gig E audio matrix systems to the lowest system cost audio amplifier applications or speaker applications, Bach is a one-stop embedded solution for all your professional audio and networking and processing needs. Bach is available via plug-and-play hardware modules, system on a chip, virtual sound card, or intellectual property cores, complete with product development kits to help you get to market fast. Bach is high impact because you can innovate freely across markets. It's also a high efficiency portfolio because the wide portfolio allows you to choose the optimum solution to match your needs. And now a quick overview of the products. For ultimate performance and flexibility, there is Bach Open Module, which supports up to 512 channels in and out, 128 streams, and 1 to 80 channels per stream. It is available in 5 different software-defined flavors, including MADI and 128 and 256 channel versions. Our well-known Bach Liberty is a drop-in footprint compatible module for Dante Brooklyn 2, allowing you to free your products and broaden your markets by having full AES67 and 2110 compatibility built in to the module to address the most demanding broadcast and uncompromising live professional audio applications. No expensive domain managers needed. It's all integrated inside the device. Bach Minarets are extremely popular, high performance and cost-efficient system on a chip for higher volume applications. It supports up to 16 channels, full AES67 and 2110, as well as Ravenna, SAP, and NMOS in an upcoming release. Bach Linux Virtual Sound Card is our technology, all in x86 software, running on Linux for commercial off-the-shelf servers and centralized applications. It's also been used in Docker applications and some upcoming products. We are also big believers in allowing you to easily manage your network your way and are rolling out Animan across our portfolio and Ross Dashboard, which is helpful if connecting to a Ross ecosystem. Now, a bit more detail on Bach Open Module. 512 channels, 128 streams. And these are both 512 channels in and out, 128 streams in and out, 180 channels configurable per stream at various sample rates up to 96 kilohertz and packet times down to 125 microseconds. Within this envelope, you have complete flexibility as long as you don't exceed any of the limits. For example, you can have 2 80-channel streams, 3 64-channel streams, 1 40-channel stream, 3 16-channel streams, or 2 8-channel streams, and 56 monochannel streams as just one example of the flexibility. You get the picture on that. We can also handle 500 milliseconds of delay from the physical network for long distances caused just by physics of the transport medium, e.g. fiber cable. This is unique innovation is to address long cross-continental networks and is demanded by some end customers of our OEMs and is being used by broadcasters today for long distance networks. One thing I'd like to point out, this technology can be used with the standard minimum output buffers as defined by AES67. So it's very efficiently implemented. 2110 AES67 Ravenna and 2022-7 headless protection switching is built in as it is in all our Bach products. In addition, we support 2 gig E5s on the module for data traffic so we can have physical port redundancy, and we have a 3rd gig E5 for out-of-band control as an option if you don't want to send your control information in band with the audio packets. The table shown highlights the various software-defined flavors available on the same open module. This is why we call it open. There's 128 256 versions, including our higher-end 512 version. We have a MADI option to AES67 with built-in ASRC, and finally a customized version where you can integrate your logic via our FPK, which is an FPGA development kit, and software via software development kit with ours in the same open module. So your logic, so you can get a fully customized solution. Now a little bit more detail on Bach Liberty. 64 channels, no hardware changes, pin compatible at Brooklyn 2, Ravenna 2110, AES67, SAP, all built in, including 2022-7 redundancy. All integrated into the module, and it just works. There's one physical gig port, so a small Ethernet switch, we use Marvell, which is needed. Bach Minuet, 16 channels, 8 streams, full AES67, 2110, Ravenna, and like all our products, 2022-7 glitchless redundancy is included, which is a big feat and very hard to find in lower end solutions. It's cost efficient even for the smallest solutions. The Bach Virtuoso Audio over IP PDK product development kit has all you need to quickly evaluate and understand how to integrate Bach technology into your products. It is a universal PDK, and it contains, it's a PDK for all our hardware-based solutions, including Bach Open Module, Liberty, and Bach Minuet, including every physical interface that's required. One benefit is that you only need one board to test out the functionality. For example, you can feed audio through Liberty and play it out through Bach Minuet as if you're communicating with an AES67 endpoint. Typically in the past, you would need 2 development boards or had to use a virtual sound card to do this. It includes a word clock in and out to monitor Ptp synchronization, Giga ports for all devices, 2 redundant and 1 control port for open module, 2 for Liberty, and another 2 for Minuet. Common features include power over Ethernet, redundant DC external power supply, USB UARTs, and JTAG connectors for programming and debug. Headers for access to all TDM signals. Finally, I want to turn to the last slide to highlight some unique benefits of the portfolio. Although Bach is used in different markets like Pro AV, I wanted to show one market example in broadcast. Bach is used by many top OEMs who sell their equipment into some of the biggest media networks in the world, and this OEM equipment is currently deployed in these networks. These listed on the slide are just some of the networks that the OEMs are participating in and where Bach tech can be found. In some cases, the end customers know their suppliers are using Bach tech as the OEMs communicate this openly. In other cases, we work collaboratively with the OEM partner and the end customer to provide support. We have debugged many other 2110 solutions developed by other companies that didn't work. Still, in other cases, the end customer doesn't know, and they don't have to know. We like it that way. We want our customer's brand front and center. We're committed to this. We also eat our own cooking, and Bach is used by Ross Video branded equipment, both for audio and video, which can be found in some cases in the same networks as our OEMs. What's the value of this for you, an OEM partner? Well, it results in a bigger ecosystem, a bigger footprint, and guaranteed interop. Our technology is being used in some of the most demanding networks in the world. It is being used in many different environments, types of equipment, embedded scenarios, and hundreds of different workflows. OEMs can count on it to work. These are situations, if you're not fully AES67 or 2110 compliant, your equipment won't even be considered. On IP live production networks, it's not just audio on the network. It is video, it is metadata, it's other traffic. On IP, it is the Wild West sometimes. Ross knows video, and Bach is used by internal video experts in their applications like our big, hugely popular Ultrix routers. As part of the other equipment, you would see that we have developed our NUT video IP bridge and our IGI audio IP bridge, and including our Raptor open gear card and some of the other products that you see in the diagram. Bach AIP has credibility within these big networks. If you're trying to sell your product, this could be a big plus. In any case, you will likely be interfacing to another Bach-based product and not even know it. It will just work. For further information, you can type in Ross Video /Bach, or if you want to go to a particular product, you can type in Ross Video /Liberty or rossvideo.com/Minuet and go directly to the products you're interested in. So thank you very much, and now I'll turn it over back to Andreas.
Let's move on. Next in line is Ari Vandenbroek from Archwave. Ari, I hope you're still with us, and I hand over control to you now. Just take it from there.
Yes, my name, Ari Vandenbroek, and I'm the CEO of Archwave. We have been one of the, just like the others, one of the first-time Ravenna partners, committed for a long time, committed to the visions of open technology and standards. Since 2018, we have become part of Riedel, and we are based in Switzerland, just like Andreas said earlier. Different than all our colleagues so far, we have a slightly different approach to the networking environment. The colleagues have high channel counts, ultra low latency. They are providing you the infrastructure to build big networks. We, on the other hand, look at the low channel count SoC-based solutions, and with a focus on ramp on, ramp off. Every network, regardless of size, will need very simple solutions to go on and off of the network. That's where Archwave comes in, with a range of modules that are fully Ravenna compliant, AES67 compliant, and provide you a simple way of making an OEM implementation. Like I said, we focus on low channel count from 2 to 32 channels, small unit size. All our systems are real-time OS, no Linux. We work close to the metal, have 100 MB connectivity, and are future-proof, meaning that our stack is more or less hardware agnostic, so we can quickly move from one system to another because the chip market is always in movement. And that makes our systems future-proof. Yes, we are, as I said, fully Ravenna compliant, AES67 compliant, and by that, of course, we have our built-in web server, 2110 compliant. A simple NMOS implementation is on the way, and obviously also NMN compliant, which is also important. So all the basic ingredients to make a successful product. Then our solutions basically comprise out of 3 platforms right now. The most simple one and the most well-known in the market is our UNet Mini, simple 2x2 in and out. Then our UNet Compact up to 16 channels, and our UNet Standard up to 32 channels. What's worth mentioning is our groundbreaking technology to do bridging between USB and network back and forth, and all the basic standard parameters, as you can see in this sheet. We basically, this is very simple and very straightforward, just like our user interface. This is a web interface addressable by any normal browser. Straightforward. Besides the web interface, we also have another way of addressing, which comes later. Typical use cases we are used in active loudspeakers, network amplifiers, audio interfaces, intercom applications, and audio players and recording. We have a fast implementation time because basically our modules are very straight and simple to implement. Our modules are completely remote controllable through our ARC protocol, and that means you do not even need the Ravenna website. You can basically implement you can remote control the modules from your host, following your own UI, your own way of dealing with Ravenna and AES67. It's up to you. We also provide low-cost development kits, and we have prepaid support packages if you need them. We are there to help, but you wouldn't need that much help because we try to keep things simple. That is very simple, our statement. I thank you for that. If you need more information on Archwave, www.archwave.net. And then, Andreas, I'm going back to you. Thank you.
All right, thank you, Ari. That was really a quick one, nice and quick dessert. Thank you very much. So I will take you through the last portion of the OEM building blocks we have, of course, from the ALC network side. So as you know, we have defined and developed the Ravenna protocol from the very beginning. And consequently, we have something to offer, helping manufacturers implement Ravenna AES67 2110 into their products. Of course, we also offer our system on the module, the IMX module. For those interested in porting the whole design into their own platform, that is the reference design, including the full source code package, is available as a one-time buyout, as well as a software-based processing stack resembling all Ravenna functionality. Some of you already know that we also have a virtual sound card for Windows available. This is a non-commercial offering. Hold on just a second. Yeah. So this is non-commercial offering for those who are interested in playing and experience Ravenna AES67, as well as for manufacturers working or trying to program against a reference implementation. And finally, most of you may already have heard or already using the RAV to SAP converter, which is basically a discovery translator between Ravenna and SAP used by Dante. So a quick view at our IMX SOM as being the first fully self-contained Ravenna implementation on the market, as that basically was our reference design. It has 128 channels in and out on 2 gigabit interfaces, supports up to 192 kilohertz sampling rate, and of course already supports what I mentioned in the beginning, the AES3 or 2110-31 AES bit transparent protocol. The operating performance goes as high as 1 sample per packet on the network. So you won't do that with a stereo channel, of course, but if you have a high performance MADI or backbone stream connection, you can actually send out packets on a sample based frequency to achieve utmost or lowest possible latency on the network. So actually MADI over IP is definitely possible with this implementation. On the other hand, we offer up to 40 milliseconds buffering per channel. So that qualifies the module for full wide area network applications where you have to deal with quite a lot of network jitter. So audio interfaces, of course, 64 channel MADI, 64 channel TDM. Alternatively, can be used as an 8-channel I2RS interface, and together with the 2 gigabit network interfaces having 64 channels each, there's a 256 by 256 cross-point matrix on the board, so you can basically connect any input, any of the 256 inputs to any of those 256 outputs. So you can also route MADI to TDM, IO, or network 1 to network 2, or whatever. So then we have, of course, as I mentioned, full AES67 and 2110 support. As another option for those who are looking into owning the code and implementing it on their platform, we can offer the full reference design as a source code package. So you would get the full functional VHDL project with all the source code, no binaries, no black boxes, everything you need to have and to port this to your own design, including technical documentation and ample support, which you would need for the porting. The software processing framework, which is also being used in the Ravenna virtual sound card, is another option. However, for porting that onto your particular platform, you would supply a Ptp client. We currently use the Ptp4L, as well as an matching audio interface driver, because we just don't know how the audio interface looks like on your particular or envisioned platform. So that needs to be supplied on your side. So that is another option available from us. Of course, technical documentation and the development tool chains come with it. So then I already mentioned the Ravenna virtual sound card. Basically, it operates under Windows 7, 8, or 10. Although with 10, we have seen some limitations most recently, which can be circumvented, but 10 gives us some headaches. But as of now, we can still solve those. It only supports WDM driver models, so no ASIO support. The typical processing latency is about 10 milliseconds. That is because we have not written too much of the code in the kernel space, but only use the Ptp interface and the audio driver in the kernel space, and all the other processing takes place in the user land or user space. So 10 milliseconds is what you can expect as a typical latency with the virtual sound card. However, there's one particular specialty you should know. Our virtual sound card, unlike others, unlike the merging sound card, and also unlike the sound card being offered by Lavo, only works when a particular Intel network chip is present. The reason for that is that we have just translated our Ravenna design, which works with hardware timestamping support, into the Windows system area, and Windows doesn't know anything about Ptp at all. So we have looked for a particular chip which is being able to support Ptp hardware timestamping. We identified a number of Intel chips which can actually do that, and so we require one of those chips being present. Otherwise, we don't have the Ptp timestamping, and the Ravenna virtual sound card cannot run properly. The free version is downloadable from the Ravenna website in the support section. As I mentioned earlier, this is not a commercial offering, so we don't have commercial support for it. Interested manufacturers who want to use the Ravenna virtual sound card as a reference software reference object to work against with their own implementation can have a full-blown virtual sound card working with up to 64 channels recording and playback. The final tool we are offering for free as well is the Ravenna to SUB converter. Basically, the problem it tries to solve is that we have various methods of transporting the SDP file between products. The SDP file is actually required for a receiver to properly receive and decode the transported payload. So Ravenna uses DNS-SD or MDNS and RTSP for the SDP transport, which is the standard method, which is also being used by most of the media players, just like VLC player or Windows Media Player. They fully understand and support RTSP method for SDP transfer. So effectively, you can subscribe to a Ravenna stream with a VLC player using its RTSP URI, and it will receive the Ravenna stream. Since it doesn't synchronize properly or the same way Ravenna does it, you will experience some pops and clicks here and then, depending on how far off the internal 48 kilohertz of that particular VLC player circuitry is with respect to the sender. Dante is exclusively using SAP, Session Announcement Protocol, for transporting the SDP information. They don't even offer manual readout or entry of SDP data. So if you want to connect to a Dante system or from a Dante system in AES67 mode, that particular device has to support SAP. Otherwise, you can't get the required SDP data out of the Dante system or into it. So, and the solution for this is we have developed the Ravenna to sub converter, RAV to sub, which basically is translating the announcements and the SDP information from one protocol into the other. So this is a very quick view how this works. We have Ravenna and Dante on each side. We add a PC in the middle. The PC is receiving all the Ravenna advertisements and can receive the SDP information. It's displayed in the left part of the screen. It then translates selected entries or all of them into SAP so that they are visible inside the Dante controller. And of course, this also works vice versa. The SAP announcements are listed here. They are translated, all of them, or selectively into Bonjour RTSP advertisements so that any Ravenna device can directly access the information without having to know anything about SAP at all. The third and very, very useful option, as it turned out, is the ability to enter the SDP data manually into the program so that any device which is not Ravenna or Dante, which just offers manual readout and entry of SDP data, can also be integrated into the network by just copy and pasting the SDP information into a manual entry screen. So if you're worried that too much data is passing through the PC, well, it's just the Bonjour RTSP data or sub data, which is actually passing across the PC, and all the AES67 streams are running directly between the participating devices, so the PC doesn't get a lot of traffic load at all. Well, unless you install the Ravenna virtual sound card on it, you have a very handy debugging, monitoring, work tool where you can receive AES67 streams and also do all the SDP, SAP, Bonjour, RTSP translation on the same machine. So that's basically what is on offer from ALC Networks, helping you to get a Ravenna into your products. And basically that concludes the technical part of it. If anything comes up, any one of us is happy to be contacted directly, of course. You will find initial information on what we just presented on the Ravenna website. In the OEM solutions section, there is much more information and resources available on the resource section of the Ravenna website, including the virtual sound card, RAV to sub software, which are downloadable for free. If you're interested, and I want to remind you that we will have Ravenna webinars now every week on Tuesday, 1500 Central European summertime. Next Tuesday, we have a very interesting webinar on how Ravenna and AES67 in particular enable innovation in the wider broadcast industry. And this is presented by Bill from Ross again. Niklas Sturme from Merging will be with us. And so that should be another interesting 60 minutes. The webinar is already advertised, as all the other webinars, on the Ravenna website in the event section. So just go ahead and register yourself for any of the upcoming webinars. So that's it for today. As always, thank you very much for staying with us. If you have any other question, any comment, just don't hesitate to shoot an email at ravenna@alcnetworks.de. So thank you, everyone. Enjoy the rest of the day and hope to see many of you next week, Tuesday. And again, thank you to all panelists, Ari, Bill, Claude, Claudio, and of course, Roland, for keeping everything under control. Thank you very much.